Hello, everybody. Today we're going to start writing into files, opening files, and also reading from files. First, let's create a file named text. For now, the text file is empty. We're now we're having a program, and the program will contain all the necessary code that will allows us to write inside this text file, and later we'll see what happened. You have something called the open function. The open function returns a file descriptor. A file descriptor is an integer value and it is a unique identifier the operating system assigns for each resources a program have access on the system. So let's declare a file descriptor variable, and the file descriptor will receive the identifier assigned to the file we want to open. So the file we want to open is called text, and it's located into the same working directory. And next, how do we want to open the file? We want to open it in write-only mode. This means we cannot read from the file, but we can write in the file. And next, we're going to write something in the file. We have the write system call function, write, then we pass in the file descriptor, then also the content, and after that, the content length. But for now, we don't have any content or content length variable defined. Let's define content, and it will be hello world. The content length will be a size t type. So this represents the number of bytes or the number of yes, the number of bytes we want to write from the buffer to the file. I'm going to specify 11 because I think that let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, 11 character. I'm going to add a line break. Now 12. So we're going to type in 12 bytes into our file. And after that, when we're done, we close the file or we release. This is a more correct way to say it. We release the resource associated with assign the assigned resource. So the close function will receive the file descriptor and will do a system call and tell the operating system we're done using the file and we want to release all resources. Now we're going to compile this code and see what's going to happen. GCC main.c, the output file name will be called program. And what next? I'm going to open the text file from the text editor. And for now, you see that it is empty. But when we execute our program, there will be something written inside. And here it is, hello world. And what happens if you write again? It is the same thing, hello world. But we can append contents to the file instead of overwriting the content of the file. We can add another flag called o append. This flag tells that we want to open the file in append mode, which means all the coming content will be appended at the end of the file. Let's compile this code and see what happened. gcc main.c, then the output file will be program. And here it is, hello world. And when you run the program, you see that hello world is appearing in the text file. This is how we write into files. Next, we have other ways. For example, if you want to create a new file, if the file doesn't exist, this will fail. It will fail opening the file. For example, I'm going to delete the text file. And what will happen if the file doesn't exist anymore? The open function, since it isn't able to find the file, it will return a negative integer, which means an error occurred. So if the file descriptor is lesser or is lesser than 0, that means an error occurred. We want then to stop the program and exit. There is a function called p_error, and the p_error function writes, um, uh, let's say we're going to say we're going to use the dprinter function. The dprinter function receives a file descriptor and a formatted string and all the variables that have to be placed in that format. The first parameter is a file descriptor. The file descriptor we want to pass is the std error file no. This is by default. If I remember, the value by default is 2, because when in the shell, by default, there are certain number of files, the standard input, the standard output, the standard error output. These files are opened by default, and their file descriptors start from 0, 1, 2. So we want to write inside the standard output error file and exit the program. In order to use the dprinter function, I'm going to include the stdio library, stdio library. So here we can say unable to open file named, and then we pass in the name of the file. The name of the file will be text. As for now, I'm going to compile this code and see. But before, let's exit the program. We type in exit 1. gcc main.c, the output file name will be program. Yes, there is a problem. I have to include the std lib library. Let's try again. Great. Program. And here it is. Unable to open file name text. So here, I don't know, I don't think if all this is necessary, but I just want you to understand that this is the file descriptor and this is the format and these are the variables we want to replace the format content with. So the dprinter function is very useful when you want to print formatted string in your files. We can use it with any file descriptor. For example, we can pass in the F file descriptor of the file we just opened to the dprintf function. This is just for example purpose. Great. Now we know that the file doesn't exist, but if the file doesn't exist, we can choose to create a file. But for now, I want to declare a variable called file path or file name. The file name will be set to text and make the program a bit cleaner. File name. If an error occurs, we can say we print a formatted string and we have the file name here. Great. There is another flag we want to add to this, and the flag is the create flag. That means if the file doesn't exist, we want to create a file. But if it exists, we don't want to change the file. By using the create file, there is a third parameter the open function receives. These are for setting the permissions or the modes of the file you intend to create. For now, we want to say the file is going to be user write enabled, so we have to be able to read from the file and also S, I, and write to the file. The first parameter, the file name, the second parameter, the flag specifying how do we want to open the file, and the third parameter is about the permission we want to set on the file at create time when it doesn't exist. If the file already exists, it won't be recreated. I'm going to delete these things, but always make sure there is no error before continuing your program. Let's compile this code and see what happens. gcc main.c, the O option. Great. So if you look at in the terminal, there is no text file yet, but we can create the text file now by running the program. The program receives the file name, and here is the flag we set on. We say we want to open the file in write-only mode, and if the file doesn't exist, we want it to be created. Remember, each time you pass the create option, you also need to pass in the third param to the open function. So this is required because if you don't do that, some random things are going to be set for the permission. So the last parameters are the flag to set the permissions for users on the file. Let's execute this code again. Now we have a text file, and also if you check the permissions, ls text -l, and here you see that a file named text has been created, and it has the permission read and write permission. And also, if you check into the file, you're going to see the hello world. So when you try to write in the file, you also might want to add the O append option, because if you don't do that, this is going to override the content of the file starting from the beginning. So using the append mode, that is very useful. Now next, we know how to write into files, how to create files and set permission on the files. You can do some search on those things. A reference will be, you can go on the GNU documentation and look for these things, flags and modes. We know how to write into file. Now let's try to read from a file and display the content of the file to the standard output. I'm going to delete all that and do it again. Let's say we have the text file here and I'm going to add something inside. Hello world, welcome, good morning, great. Okay, let's declare a file descriptor. The file descriptor, what it will do, will receive the unique identifier the operating system assigned to the resource, here the file, and we also have to declare what we call a buffer. This allows us to read from the file. So I'm going to say char content, and the size will be, we're going to be able to read at least 32 characters at a time, and the content size is going to be size type content size is equal to 32. And what else? We have to open the file, open, and assign to the file descriptor. I forgot to define the file name. The file name will be text. We have to provide a path, the absolute or the related path. So the first parameter to the open function is the file name. Since we just want to read from the file, we open it in read only with the read only flag. We don't need the third parameter because we're not creating the file. And next we have to check if the file opens successfully, but I'm not going to do that, but always make sure if the file opens successfully before continuing. Next, we tap the code, all the code here to read the file. And when we're done, we close the file. Let's start by reading from the file. So we have the read function, and the read function receives the file descriptor and the buffer, or the variable that's going to receive the content, and we also have the content length, size. The read function is going to return the number of bytes it was able to read. So if it returned minus a number lesser than 0, that means there is no byte left for reading. So I'm going to type in s size t. This is a type used. It is same as the size t tab, but it supports the -1 negative number. So we say and read equals 0. Let's read from the file. So we start by saying do, or we can just say while and read is greater or equal to 0, that means we can read from the file. Then we say and read is equal to read. We pass in the file descriptor, the contents variable, and also the number of bytes we want to read. But if there is no bytes, the read function anyway is going to return the number of bytes, but it was able to read. So this is the maximum. The content size would be the maximum number of bytes we want to read uh, at once. Then next, when we read, we can now write to the standard output. We use the write function. The standard output file descriptor, we use that. So the write function is going to know where it have to write. We pass in the content and the end read the number of bytes read from the file. But before that, we always have to make sure if the number of bytes is greater or equal to 0, because if the number of bytes is lesser than 0, it means it's greater than 0. It means we can write to the file to the standard output, but if not, we cannot. That means there is no byte left for reading. And next here we close the file. I'm going to compile this code main.c, and we pass in the program as output. And now let's have it. Yes, it works. The file didn't close, but I think there is a problem. Let's say, because if the number of bytes is 0, that will create an infinite loop. Read is going to return 0, 0, 0 each time, and we don't want that. So I'm going to say use a do while loop. So do while and read is lesser than while and read is greater than 0. So let's try that again. I'm going to compile the code, and here it is. Great, we've been able to read from a file. Now, so this is how we read a file, and we also write to the standard output. We can write to whenever we want, but here we just want to display something on the terminal. The write function also returns the number of bytes it was able to write to the output file. But if it returns something like -1, that means an error occurred. You might want to make sure all these things are checked correctly before continuing in your program. So this is it today for how to create, read, and write from files. Thank you for watching. Do not forget to like and subscribe.